So before we begin today, I would like to acknowledge that I am joining you from the traditional unceded territory of the Algonquin and Anishinaabe people. I am Carolyn Longton, the National Lead for the Coastal Environmental Baseline Program, and my colleague Brian Campbell is also here with us today. We would like to thank you all for your interest in the data management training sessions for the DFO Coastal Environmental Baseline Program being led by the Saint-Laurent Global Observatoire, or SLGO. SLGO has been a valuable coastal environmental baseline program partner, helping to support our partners with their data management and publication of program data since 2019. And this workshop builds on the success of our Coastal Environmental Baseline Program's National Partner Workshop in the fall of 2024, and the information that was shared and the connections that were made during that workshop. We hope this workshop will help strengthen your knowledge of data management and structuring and provide you with tools to assist you in data publication as we near the end of phase 2 of the baseline program. The publication of baseline data is fundamental to the success of our program and benefits all Canadians by making these robust data available for decision making. Now, I see most of you have already done this, but before I hand things off to SLGO, I'd like to ask that you rename yourself just so that we can match names to organizations. So if you could look at my name and just put your name followed by the organization or affiliation, that would be really helpful for us, please. I would also like to mention that translation is available in Zoom through the use of captions, and questions can be posed during the sessions in French or English. Je tiens également à mentionner que la traduction est disponible dans Zoom grâce à l'utilisation de sous-titres et que les questions peuvent être posées en français ou en anglais. So thank you all for joining us over the next 2 days, and I will hand things off to SLGO to get us started.
Thanks, Caroline. Hi, everyone. It's really nice to see you all. Bienvenue à tous. So welcome to the Coastal Environmental Baseline Program Workshop. I'm Mathé Couturier, Scientific Director at SLGO. And first, I'd like to say that SLGO wishes to emphasize that it is located on the Wallace-to-Cook, the unceded Wallace-to-Cree territory, and more specifically on the portion occupied by the Wallace-to-Wick-Washapekuk First Nation. LCGO also recognizes that the Mi'kmaq First Nation of Gaspé-Gigawi claim a large territory, which includes the Wallace-to-Cree reserve lands. This indigenous nation and the respective territory are governed by peace and friendship treaties, and it is crucial to emphasize that these treaties do not address the cession of land, water, and other resources. As Caroline says, the workshop will be in English. You have translation available. So, dans la section de Zoom, dans les sous-titres, juste en bas, si vous cliquez, vous pouvez activer la traduction et langage parlé anglais, traduction en français. Si vous avez quelconque problème technique, écrivez-nous dans le chat, puis on essaiera d'y répondre au mieux. If you have any issue with the Zoom, tell us in the chat and we will try to answer the problem. A reminder that the workshop is recorded, and we will share the slide of the workshop in the coming days after the workshop. So the slide will be shared both in French and in English. Now I'd like to introduce you to my colleagues who are going to navigate you through the workshop in the next 2 days. So Omnain, which is a data scientist and the lead of the baseline program. Maria Emilia, and Jeremy, both data scientists responsible of the integration of biodiversity data. Antoine, data scientist as well, in charge of oceanographic data, and Juliette, data scientist with a specialty in social science and sensitive data. Gabriel is the project coordinator, but currently unavailable for the workshop. If we can, Juliette, si on peut passer à la slide d'après. Thanks. So the objective of today's workshop are to introduce you to principles and practice of data sharing, which includes the challenges and best practices, how to organize files and folders within a project, which term you can use or not to better organize your data, and finally, some example and common issue in data management. So today it's a big afternoon. We will have a break in the middle of it of around 30 minutes. If you have questions, please use the chat. We will answer them at the end of the afternoon, where we have like a period of 30 minutes for question and discussion. And have a great afternoon. Hope you will learn a lot of things. And Juliette, to you.
Thanks a lot, Mathilde. Thanks, Caroline and Brian and everyone for organizing. It's a pleasure to have you all with us today. So we'll spend 2 days with unrepentant data nerds, and I'll start us off with a brief introduction on SLGO and the principles that have guided open science and the open research movement over the last few decades. So SLGO, we're a nonprofit funded in 2005, and we celebrated our 20-year anniversary last November. Maybe some of you were there. And from its inception, the goal of SLGO has always been to become a central access point for data on the Saint-Laurent River, its ecosystem, but also more recently, its communities. We have a diversity of partners and members, government agencies, other nonprofit communities, and university research group. And our role is not only to share data coming from these partners, but also curate it to reach international standards and norms and ultimately make it interoperable with other repository and system. I'll come back to some of those words later. And all of that is done to the benefit of the ecosystem and human and non-human community who inhabit them. So as I just said, SLGO has a ecosystemic view, meaning that as we are faced with the historic challenge posed by climate change, SLGO is mobilizing and to disseminate as much data as possible to contribute to informed decision-making and a better understanding of marine ecosystem. This vision motivates us to reach out to a multiple of partners who can help in order to help them manage their data and improve their quality and interoperability. What do we mean by data serving ecosystem? So one important value of SLGO is that we're here to enable political actors and community to make informed decisions based on science. And this is not only done by sharing data about ecosystem, but also identifying gaps in knowledge where more data might be necessary or more research might be needed. Mathilde briefly presented the people who are going to speak today and tomorrow, but we're part of a much greater team that's multidisciplinary. The SLGO is made out of 3 main components, work collaboratively. We have a team of data scientists who are well represented today, that come from a range of disciplines, both natural and social sciences, with a strong emphasis, of course, given our mandate on oceanography, with specialties in geology, biology, physics, chemistry, and so on. We also have a coordination team, which takes care of our outreach, our project development and communication, as well as fundraising. And we have a well-developed technical expertise coming from our developers who work on international and public tools to visualize data, automate our processes, maintain our platform, including one that I'll present to you later, our catalogs and maps. Our expertise over the last 2 decades has developed on key areas of data management, dissemination, archiving, and valorization. We work both with data producer and data user, And we offer support and training, like today, to our partner in the management of their data. We process data sent to us by partners to reach international standards and norms, and our development team works on in-house tools to automate and integrate and facilitate and assist our data integration pipeline. They also create tools to visualize data in a way that speaks to user and that serve the broader public. This showcased our an up-to-date gallery of our members. As mentioned earlier, we have members coming from a broad range of professional field. They're brought together, of course, by their interests in the Saint-Laurent River and its ecosystem. But as you can see, we have a broad range of members. A little note on how this global system of ocean observation works. So at the international level, we have all the ocean in the world basically are observed by different observing system. Euro goes for Europe, US for the US, and since 2019. So quite recently, SLGO has been part of a pan-Canadian initiative to integrate ocean observation at the national level and creating CEUS, Canadian Integrated Ocean Observing System. And we are one of 3 regional association member of CEUS, along with a Pacific one and one in the Atlantic. Just a little note on how CEUS works. Basically, all the 3 regional organizations communicate with data producer to process their data, and then it's all harvested by our national portal. So all the data that you will find in each of the regional association, SLGO, Pacific, and Atlantic, will be found in the CEUS catalog, basically. As you know, so SLGO is connected also to a network of oceanographic data management experts. Data shared by SLGO undergoes curation, processing, and compliance with international data management standards, and they are revised, evaluated, adopted by the international community, and hence many members of our data teams are sitting on those different bodies and working group that observe and set those standards, that allows us to keep a constant watch on how they're evolving and enabling us to stay relevant in this ever-changing environment. Our role in Baseline is to support the management of data for both governmental and non-governmental organizations working in this program. The way we work with CEBP, we aim to work with partners as early as possible in their research process, because basically sharing your data is the last step of a long path. And if your data is well organized and well characterized at the beginning, it makes this last step much less painful. The concrete term, it consists of offering free support in your data management need. This includes personalized support to bring data up to standardization levels and ensure their long-term preservation. You also have available on the CEUS website and SLGO one a data management guide that's available both in French and in English. Secondly, we aim to ensure that the data and metadata are accessible and interoperable, and this creates a common path for all the data coming from Baseline, and promote a comprehensive understanding of the ecosystems under study, and offer a local community a point of access for all this information, and in turn inform decisions that are made by policymakers and so on. A concrete example of how this can be achieved will be shown through this presentation, and we'll come back to notion like interoperability a little bit later. Let's just say for now that the idea is that we apply, by applying different standards, different data files can be easily communicate to each other using the same kind of languages. The SLGO data ingestion pipeline, just to give you an idea, if you haven't already communicated with us and need to do so over the next few months or years, first we have an initial contact. So once you have data to share, or earlier the process, if you need us, you contact us via email, you send us your data, and as well as the metadata. And then we go through a iterative phase of back and forth where we ask you questions and make things clear. We send you as well our, and I'll present that later, but our metadata entry form. Once we have a preliminary version of your data sets and the catalog page that's ready, we'll send it to you for approval. Again, there can be back and forth if we made a typo or there's some change that needs to be done. And once the final version is approved, we push it through our production catalog. The dataset is published and publicized through our social media. Now that I've presented briefly the SLGO, I'd like to go a little bit more abstract and talk about the general principle of data sharing, because the work that SLGO does basically is not done in a vacuum. It's part of an ecosystem that's been developing over the last few decades on sharing data and making data available for different audiences. So as you might know, replicability is one of the fundamental pillars of the scientific method. Without it, we couldn't confirm earlier work, and scientific knowledge become unstable, and further research risks to be based on weak and inaccurate foundation. By being able to replicate a protocol, we can assess the falsifiability of the results. You might have heard the term replicability crisis. This was identified in the early 2000s when there were tests to replicate former studies, and as you see on the graph on your right, with varying success depending on the discipline. But it showed the way for a larger movement for open science and open research, where a researcher would have to show how they obtained those results. This has many benefits, some of them at the individual level. First, it helps save time. We all know that data collection can be a very costly, in terms of time, in terms of resources, endeavor. And so if we're reusing data that already exists and is available and it's well characterized, it saves quite a lot of time. At the individual level, again, it can help build a network because it increases the visibility of research that already has been done, presumably by researchers that have the same kinds of interest as one does. There's also environmental benefits. It avoids recollecting the data and duplicating storage, which is increasingly costly with the amount of data that's been produced. And finally, there's societal benefits. They increase research impact by better disseminating the research. And as a note as well, this becomes also a requirement by many funding agencies throughout the world, and we can expect Canada to adhere to those guidelines over the next few years. So as part of this open research, open science movement, some principles were agreed on by groups of researchers. The main one is the FAIR principle. They offer guidelines for anyone who wants to make their data easier for reuse, and they were defined during a workshop in the Netherlands in 2015. So it's quite a recent endeavor. And so it's I'll go over quickly what the FAIR, the acronym means. Findable means that the data should be easy to locate, both by human and machine. That can be done through unique identifier or descriptive metadata, and that it ensure their presence in their index is present in both regional, international discovery portals and search engine. A stands for accessible. Once you found the data, it should be easy to retrieve using standard access method. We recommend open access formats. It should also be interoperable. Coming back to that word, so multiple systems should be able to detect, analyze, and categorize the content. And to do that, the documents need to be standardized in some way. And so it means a common programming language, the use of controlled vocabulary, non-proprietary formats, as well as reference metadata. Our systems are compatible, for example, with so SLGO systems are compatible with international one like OBIS and GBIF, and we'll come back to that as well later. R stands for reusable, so should be well described and properly licensed, meaning one should know how it can be used. Again, it should have all the related documentation that will make its use reliable. I would like to point out, however, that although the FAIR principle have achieved consensus in the international community of data manager, the FAIR principle tend to only consider the data in and of itself and not the environment in which it was created and produced. It might not come as a shock, but data is not neutral, and behind the choice of where, what, how we collect, analyze, and share data, there are social, ethical, and political considerations, even though they are not expressed as such. The main response to the FAIR principle came from indigenous communities who pointed out that other principles might be necessary to take into account the rights and interests of those groups that have been historically marginalized by mainstream science. The Global Indigenous Data Alliance writes, the insistence on increased data sharing creates tension among indigenous people who at the same time demand greater control over the use of data concerning them in order to increase their collective benefits. And that's where the CARE principle come from. So the first C stands for collective benefit, in the sense that the data that's produced using indigenous data and knowledge should must create value for indigenous people and not just for the researcher, institution, or system. The second letter, A, stands for authority to control. The right of it reflects the rights of indigenous people to govern how data about them is collected, used, shared, and interpreted. It also calls for our responsibility to build a respectful relationship, to ensure data is used in a way that are accountable, and recognize that stewardship of the data by indigenous groups is not optional. Demands ethics in terms of the decisions that are done that must prioritize dignity, rights, and well-being, and not convenience and extraction. CARE is about shifting from data practice that take data governance that protect, empowers, and uplifts those communities. In Canada, First Nations also came up with their 4-word acronym. It's OCAP, and it stands for ownership of your own information about their communities, resources, lands, and importantly, waters. Control of how the data is collected, used, and shared. Access, so that the community have access to their own data, regardless of where they're stored. And possession, the physical hold and management of the data to ensure their control and security. we might come back to those ideas tomorrow when we discuss sensitive data. So if we are collecting or analyzing data coming from indigenous communities or their territory, don't hesitate to reach out. We'll find the best way to assist you in putting protocols in place for attribution and to stay as close as possible to those OCAP principles. So how to improve data reuse? We discussed a lot of things over the last, I don't know how long I've been speaking. So first you have proactive data management, so monitoring and organizing the data, the use of open format, documenting the metadata, assigning a unique identifier, depositing in specialized repository or catalogs like ours. And so over the next 2 days, we're going to discuss these different ways to improve data reuse. So for the last section here, I'll go into the practices of data sharing. It's going to be a little bit more abstract, a little bit more practical. So we all know, maybe it's us, a researcher who still have their data on a floppy disk or a USB stick somewhere, lost in our drawers. And we also know that it was very expensive to create this data and ask of us a lot of headaches and so on. And so if they remain in this physical object, they are unusable after a few years. So this is why the data practice have evolved into repository, but as it evolved, we realized that those repository were also kind of a dead end if we didn't have any idea of how and when and the data was collected. So that's how the community of data manager has developed a common language to promote the reuse of the data. This has been a growing awareness, and there are many repositories who are just receptacle for data, but that's we put an increasing emphasis on good metadata that facilitates the retrieval by users. This is our catalog. That's one of the main output of SLGO. It's populated with data set coming from our partners. There are many ways to search in our catalog. One of the most important one is through what we call EOV, essential ocean variable. As you might know, these variables are considered critical to monitor and observe a part of the Earth system, in this case, the ocean. They cover the physical, chemical, biological aspect of the system, and since they are measured and collected in the same way, they can be compared globally. These variables were identified by GOOS, which is the Global Observatory Systems, and from the outset, it's becoming increasingly common to use those. Also, through this presentation, you'll see some blue boxes, and once you get the presentation, there are hyperlinks where you can click to and get to the catalogs or other links that we've hidden throughout the presentation. So our catalogs. So once you select an EOV because you're interested in fish abundance or so on, you'll get to a list of the corresponding data set. Here there's 79 that have been found on the that are labeled with the baseline project. And if you click on one of the data set, you end up on what we call a catalog page. On the left-hand side, you have the organization which collect the data. On the left-hand side, you have the metadata, meaning the title of the data sets. It's a short description of what's in it, a persistent identifier, the license, and here a way to download it in an open format. That might be a good time to talk a little bit about persistent identifier. These are unique string of numbers and letters that make possible to identify actors, so individual, but also organization and scientific output. Importantly, they also can be linked. So an author with his ORCID can be linked to an output, so an article or a data set, and to an author can also be linked to an organization to its ROR. I should also note here that SLGO is licensed by Dataset Canada, the national consortium that manage DOIs in Canada, and we're able to mint research outputs such as datasets. So if you need that, we can provide that service for sure. If you go down on a dataset page on the catalog, you'll find additional information. We come back to those EOV, essential ocean variable, and other metadata such as the spatial and temporal expanse of the dataset. Importantly, as I mentioned a few times, our catalog is interoperable, meaning that it's not only found on our portal, but also on the one of the SUS at the national level in Canada, and international ones such as GBIF and OBIS. That's all thanks to the metadata that our other platforms are able to harvest our data. So GBIF is Global Biodiversity Information Facility, and OBIS is the Ocean Biodiversity Information System headed by UNESCO. What does metadata look like? So that's the norm ISO 19115. That's the norm one should follow, and that evolves regularly in terms of how to describe your data. And as you can see, it can be quite cryptic and very difficult to fill out by hand, especially for people who are not used to that kind of language. So SLGO with partners has been creating what we call the metadata entry tools. This will take you, it's basically a form that will take you to a list of questions. It's going to ask about the name of your data sets, its description, whether there's a taxonomic classification or not, the place where you collected your data, as well as contact, ideally with, again, if you can put the ROR or ORCID of those people, it's quite good. And then it's connect automatically to this XML file, and it's like the form, the metadata entry form creates a XML file that's compliant with this ISO norm. And this is what we use to populate all the information that's on our catalog page that we've seen a few slides ago. Just to come back briefly on what we do in Baseline, we have dedicated a catalog map to this project that it identified the dataset created. A new version, I think, was published last December, and we're going to come back to this map, I think, tomorrow with Antoine. But just suffice to say now that what we would like to do with this map is to have identified all the data sets coming from Baseline, both from DFO scientists, but that were shared to OpenGov, our data collected by other external organizations. And that regardless of if you decide to publish through SLGO primarily or through another repository. From an IT point of view, it's something that's quite feasible. It's just like international portals are able to harvest our dataset. We can also add to our catalogs data sets coming from other sources like OpenGov or Canwin or PDC and so on. In this scheme, SLGO catalogs act as an intermediary, and as mentioned earlier, the Baseline dataset map and the catalogs are interconnected. So in this scenario, it would be possible to harvest the dataset hosted by other portals. and display them on the map along with all the other data sets that were collected as part of this program. We could also see new dot, which could, for example, have a different color depending on the source, external to GSLGO or not. And I just want to show you a little bit more what it looks like when we click on this catalog map. You have all the data sets on your left and then the map on your right. As you can see, we have more than 70 data sets and counting coming from all three oceans and the Gulf. And if you zoom in, you can click on a specific data set here and know on the right side whether it who collected it and have all the metadata available with one click. And this, I hope, reinforces the idea that properly filling out the metadata entry form that I showed you a few slides ago is really important, because that information will be found on our catalog, on the map, as well as on other portals. I'll briefly conclude by showing you another map that's called OGSL Mapper, and unlike the baseline map that I showed earlier, this is not done at the dataset level, but at the variable level. So the points we see come here from different datasets, but and you can filter by different by species or by region and so on, and it can be very useful to kind of have an idea of what was collected in certain areas. And this is possible because the data were normalized and put up to standard with what we call Darwin, what everybody calls Darwin core standards, and so OGSL can use the data coming from our catalog and populate these areas. And this has a real effect on the use and reuse of data sets. So I want to conclude by a concrete example coming from the ZIP de la Rive Nord de l'Estuaire. They had their data sets published, I think, in 2023, and a year after, almost, it had 21 citation, which is very good. And but if we look at this year, last year, 2025, it went up to 87 citation, which is an impressive visibility for a data set like this. And we have basically an increase of 314% in terms of citation. And this was done because, when the data was good, it was put to standard with Darwin core by our data scientist. And it was also, I hope it shows that one benefits from adopting good management practice, which Omain will present in just a moment, the use of the right platform, basically, to share your data, and the expertise available in data management, and to strive towards standardization as much as possible. So if those don't convince you, I don't know what will. I'll now give the floor to Omain to dive into data management practices.
Thank you, Juliette. Oh yes, I'm going to share my screen now. Sorry, it came for the beginning. Well, this is a recap from what Juliette said. Okay, so we're here. Just a little reminder, the persons that enter into the presentation, just don't forget to inscribe your name and your organizations for us to make a list of the participants, and and the MPO, DFO will use this list to the report, and also to see which participants came to the workshop. So now that Juliet talked about the principles and the importance of the metadata, we can talk about now the data practices. So to begin, the challenges that has been in the metadata in the data practices. So at first, one big challenge was having so much data that it became really unnecessary to organize it. Some principles were defined, like Juliet mentioned it, but these principles, it helped how the data was managed, but there were no clear conventions on some other details, like this variable must be named this way, or this structure must be done in that way. So from these principles, many different data practices appeared, and suddenly everyone had their own practices. So as a result, it became difficult to know which ones were truly the best. And in general, choosing a good practice often depends on how widely it is adopted. And the more organizations and the more countries use this practice, the more it tends to become the best one. So a practice that no one else uses, even if it seems to be very good, it may not be the best option. So this is why it is really important to have a community of practices. And it allows people to share ideas, to compare approaches, and slowly and strong to begin to create stronger practices. And this is why this is a differentiation on good practices, better practices, and the best practice. Here are some points to help to distinguish a good, a better, and a best practice. For example, a good practice can be the one that is a practice that is formally documented and openly available. And then it becomes a better practice when multiple institutions use it and it follows standards formats. And then it becomes a best practice when expert panels endorse it and their protocols are in continuous improvement. But it is always important to remember that practices are evolving, and that is why it is this communication with the community, it's really important to tend to this best practice. I think we never arrive to the best practice, but we are tending to. So we will talk about something that supports these practices in everyday work. For example, it is very important to have a good file organization. This is the starting point for data management. It is really important to have the files organized since the beginning. So without a clear structure, even methods become less effective. This is where organizations play this central role. So a clear structure helps to apply best practices consistently, to keep data traceability, and the data management becomes more efficiently. A key point to remember is also that you are the first user of your own data. And if files are not well organized, you are the first to have the consequences. So for example, going back and forth, having doubts, confusions, duplicate files, and also loss of content. And it can become a little confusing, all this. On the other hand, good folders organizations help us to work faster, to find information easily, and keep continuity, even after weeks or months or years. And also, we usually trust our memory, but when we step away from a project, the truth is that small details are easy to forget. So something that you think that you can have in your memory now, in a few weeks or years maybe, is going to get out to your memory. So if file names are unclear and the structure is messy, it's easy for anyone to get lost. And also, projects start with only a few folders, but as they grow, they can quickly end up with many folders and that are hard to understand, go messy all the way. So there are always these many files, different formats, several versions, etc., and etc. It's endless problem. So, and this becomes even more complex when we share data with others, or when data needs to be used in 10 years. So that's why it is very important to organize the files since the beginning. So in short, the file organization facilitates locating files, make it possible to group similar files, help easily identify which files need to be backed up, maintains organization over long term, that's 10 years, 20 years, 30 years, we don't know, and increases the productivity, helps preserve and maintain a record of the projects, and allow others easily understand the projects. But because maybe we can understand what we are doing, but when we share it, maybe the other person can understand nothing, or there are a lot of rotation of personnel, so that's also problematic sometimes. So if everything is organized, it's going to be better for everyone. So ideally, we should spend some time at the beginning to think about a clear and adaptable structure that keeps files well organized and can evolve as needed. This small time investment at the beginning saves a lot of time later and improves productivity. So now let's look at this example. This is an example of a file structure. It's something that we propose, but it's just an example. Okay. This folder tree shows how clear an organization can be created from the start of a project. So we can start the tree folders with the project. Like in this case, we can say baseline project. Then baseline project, everyone makes data collection yearly or seasonally. So it is always good to separate those files by years. And then when you see the data collections by years, you can then pass to classify the folders by geographic locations. Then, when you have this geographic location, the information that you collect can be divided. For example, you can make a folder from all the data, then another folder from all the reports that normally it's going to be later that the reports are going to be created. And the figures like, I don't know, images or videos can also be placed in other folders. And then when, for example, you have all the data in the folders, in one data folder, you can separate from every instrument or experiments that were done for this project. So for example, the fish abundance, and in this folder, you have all the data, the data in there. So there is no single perfect method you can choose. And you can choose a system that works really for you. It depends on each person's needs, and some cases can be more complex also. What matters the most is having a structure that stays consistent and homogeneous. So you can ask yourself, is this system only for me, for my team lab, for partners? It is going to be structured like this in the future? So this time that you invest is the time for example, this hierarchy. So beside the folders, you can have also the text files that it can be like a README. And this README, it contains all the information that, for example, a folder needs to be explained. So imagine a folder full of files with no explanations. It's easy to get lost trying to understand them. And so to avoid this, we can add a simple text file in each folders, in each levels. It depends of the information that you have. They give context and shows also the metadata. The metadata is really the information that you can add to the project. And well, if you have these text files, for example, others or even you in the future can understand this data easier. And you can think of this like a map that helps to work you faster and better. And any notes that helps explain the structure, the project information, or why some analyses were done, it's good to be placed at this moment. And you decide in what level you can put this information. But also, it's always important to keep in mind that the metadata, the global metadata of the project, it's always good to put it in one single file. This includes the project title. For example, in this case, you can see the title, the description, the collaborations of the projects, the methods used, and so on. So this is like the metadata, the global metadata. And this could be put in the first folder, baseline folder, for example. And in this case, okay. And also you can have the metadata of the data. That is not the same that the metadata of the project is really associated to the file that you are generating. Okay, so this data explains the data itself, and we can call it a data dictionary. This is the way that we include it in the catalog of the SLGO catalog. And this explains the variables with their units, the codes, identifiers that you use, methodologies, a list of instrument use also. And ideally, every data should have its own metadata. This is an example of a folder. So there is a folder, then the data, and then the metadata. Yes, I can point it, and then the metadata. And then, for example, in this case, you can see that here there is a variable that it meant CIL-MM. So we don't know what it is in this case. But if we have a data dictionary, we can know that it is the total length of mussel in millimeters, for example. So we encourage always to have variables more comprehensive, but if you can't because you don't have the way to do it, so this is a way to keep the data, the metadata comprehensive. So this variable issues is something that then Jeremy is going to talk about, and how we can solve this kind of uncomprehension. I don't know if we say that in English. And another best practice also is to keep the raw data in untouchable. So the real raw file, this should never be modified. So keeping original data unchanged allows us to ensure traceability, go back to the source if there are doubts or errors. And these raw files are our safe starting point, so we can always return to them. And this is the way that it should be, it's the best practice to do it. So keep the raw data in touch. And then if you have to perform analysis in Excel or other analytic program, you can always work in a copy of the files and not directly in the raw files. And the same if you have to make scripts with this data, you can place it in other files, but try not to touch the raw data. And so this is from the raw data. And this is another way, once the files are well organized, so you can enhance the data management with, for example, tags. That this is like keywords that you can define in your system. So, for example, in Windows 11, you can add tags in your data, or perform all categories that you want. So tags add extra context and make files easier to find locally. They don't replace folders, but they complement folder organization. And it is a way to help search faster. For example, big projects, it is a good way to find this project easily. It is important to use clear tags conventions, so everyone uses the same words. So choosing good tags requires some thinking and agreement among users, but it was worth it. So this is just to enhance a little bit the organizations of the folders. Okay, so this is also like an example that we have here in the slide. This is an example of what everyone has done and in their naming of the files. So like you see that there are lowercase, uppercase, some points, and it's really not easy to understand quickly what are we going to find here? So this is a good practices on how we can name correctly the files. So for example, in this case, all that is red is like not the best way to do it. And when it's in red, it means that is what the best practice. So in this case, you can see that data is not sufficiently descriptive. It's just data and that's it. So in the second case, you don't know the one, what does it mean? Is it a station? Is it a month? And so we don't know what it means. And then in the third case is that there is no file extension. So for example, there is sometimes that maybe it's not the naming of the file that you have to take care, but is also that the file has an extension. Because if the file doesn't have the extension, it's not going to be easy, no program, no system are going to open it. So it is important to add always the extensions in each file. So in this case, you can see that you have the site information, what parameters we have analyzed, and in what time did we do it. Then also it is important to separate the different parts of the file name using or the underscore or the hyphen. And this is to add more information in the naming of the files. So if you have this, I don't know how do you say the bar, the slash, thank you. So you have the slash, this is not a good practices because some systems, when they read this name with the slash, it creates some errors. So also with the spaces, when you have spaces, they create some characters to replace these spaces. So it can be difficult to process from some systems. Also, it is good to maintain some hierarchy to name the data, for example, the organization, and then all the other informations on the same hierarchy. Other practices is if you are going to name, to use dates in the naming of the file, we propose to always use the norm that is the ISO 8601. Sorry, I do it in French all the time, so in English it's a little bit different. And this is when you put the year at the beginning, then the month, and then the day. So because in this case, you can see that here, we don't know if it is 2025 or it is in 2012. Is this the month, is the year? So if you always homogenize the naming with this norm, it's going to be easier to comprehend, to understand. Other best practice is to use always the lowercase to name the files, or the camel case. Camel case is when your first letter is in uppercase and then the other letters are in lowercase until you have the separate word. So this is the two ways that it's proposed to use to name the files. Then also, it is good to limit the file names to less than 32 characters, because too long, it's impossible to understand. And also some systems can open the file when there are more than 32 characters. So you can put all the informations that is necessary, but don't exaggerate it. Also, it is not good to put characters in the naming of the files, and this is the same. The systems can have some problems with it. So instead of this, use underscore or the hyphen characters. Okay, and then in also what do you say, the parentheses? I don't know if you say parentheses in English, sorry, but you can change it for underscore. And then if you have sequentials numbering, it is better to always add zeros at the beginning of the number sequences, because what is done is that is alphabetically sorted. Sorry, and then in this case you can see the number 2 should be here instead of the 10. So it's not very understandable or clear that this is the sequence of the files. In this case, when the zeros are put at the beginning, you can see it's well sorted. And also, we wanted to bring the versioning section, because version management allows you to easily find the version you are looking for while avoiding overwriting an important version. But it is, normally we can always like put the latest version, the last of the last versions, data do not touch. So this is not a good practice. The good practice should be that you put the same name at the beginning, and then you can add a sequential number to make this is version 1, this is version 2, this is version 3, and it's easier visible, it's easier to look and than this one. Then also you can use date to distinguish between successive versions. So you can see here, and it can be the same way that we talked minutes ago, the year before, and then the month, and then the day. And you can see it's clear visually in this way. The only issues is that if the data was made the same day, it's not going to be ideal to do it with this method, because it's going to be the same day. So you have to differentiate each one of the files in somehow. Also, you can use ordinal numbers for major version changes, and letter for minor changes. So the major changes, you can use version 1.1. Then if it is a version a little more, you change a lot of your data, for example, so you can put it version 2. But then for minor changes, it is better the letter like B1A V1B, V1C, and so on. It is not necessary to create a new version of files for minor changes. So if you change just a little thing, it's not necessary, but you are the only one that can judge when to create a new version. But that's why you don't have to make a lot of versions neither. So you have to judge. So this is a little bit the information that we wanted to transmit in this first time of the sessions. I don't know if we have a little bit time before the break. If anyone has any questions that we can answer right now, and if not, we are going to the break that we have a maybe 30 minutes break. So if you have not any questions at this moment, you can use the chat, and we're going to come back at 2:15. So if everyone is agree with that, we are going back at 2:15. So thank you.
All right, it's 14. And so yeah, we'll wait maybe just 2 minutes, and then we'll continue with the presentation. For those who are back, don't forget to write your name and your organization so we can know who is there and from which organization. Thanks.
I'd like to test if we hear everyone's. So Juliet, can we test with you? If we can hear you, just to have a test from our side.
Please go. Et Juliette, juste pour être sûr que notre audio fonctionne bien, veux-tu nous parler juste un petit moment?
It's working, ça marche, Jérémy. Je pense que c'est plus du côté de Juliette, j'ai l'impression.
Excellent. All right, so we'll resume the workshop. Welcome back. I'm Jérémy Campo-Poirier, as Mathilde presented me earlier, data scientist. So I'll be presenting for the rest of the workshop, and then we'll have maybe 30 minutes for questions and other stuff at the end. So just a little reminder of what we saw earlier today. Well, before the break, Elaine showed us how to properly structure our folders and how to name our data files so that we can easily find them back among all of our folders and files. But there's also one crucial factor to consider, and it's the file format, because you may have named your file in a very clear way and organize your folder very well, but then if you choose a format that's not reusable, that's not accessible to everyone, then that's also a big problem, because it then kind of become a waste of organization in your folder. So the format has many implications, and you want your file to be reused either just tomorrow, but in 10 years as well, and even on the even longer term. And you also want it to be accessible. So by that, we mean in open source. So you don't want it to be proprietary. You want it open, ideally non-encrypted, unless it contains sensitive data. And about sensitive data, we'll have a presentation by Juliette tomorrow on that kind of data. And also non-compressed, although like zip files are fine, but some other format that are compressed might have some interoperability issues. And also some formats are proprietary, so they're not considered to be an open format. So yeah, like for example, I think in the audio files, WAV and MP3, I can't remember which one, but one of them is compressed and the other is not, so make sure to pick the right format. But with all that being said, we're not saying go back to all your files and switch them to an open format. You don't have to do it right away. You can still use, for example, Microsoft Excel, and actually at SLGO, that's kind of what we do. We still work on Excel files to standardize the data, but when we're ready to upload it on our catalog, it's at that moment that we'll switch to a more open format, such as CSV. So you can still keep working on Excel, but at some point for the data you want to share maybe publicly or with partners from other organizations, you might want to switch to a more open format. Internally inside your organization, again, it's not really necessary, but it can be useful for long-term when archiving some files. Because you might know, when I was younger, actually, I thought the Microsoft Office softwares were just included in my computer for free and that I would be able to use them all my life, but actually not. They come with a license, and it's not everyone who has that license. So if you're sharing files with colleagues or friends or other organizations that might not have the Microsoft license, then they won't be able to open or to work on your on those files. So you can use the ODF, Open Document Format. It's an open file format standardized for Office automation, and it guarantees interoperability, long-term access, and independence of any software company. Because another weakness of the Microsoft Office suite is that if for any reason Microsoft was to close and all their software become unusable, you can't work on your Word or Excel files anymore. So the ODF suite has different format. So ODT for Word, ODS for Excel, and ODP for PowerPoint. And there are also other formats that are more open than, for example, Excel files. So in this case, you have CSV, like I said, ODS, but also text and NCCSV. And those are among many other type of open format for different type of files. So for example, with Excel, you can switch to CSV when it's for exchange and analysis, ODS for just sheets and style, NetCDF when there's a multi-dimensional aspect to your data, PNG if you want to create to have a direct web display, and GeoTIFF for georeferenced images. And all of these formats, except for NetCDF, can be easily opened from a text processing program. So just with Notepad, for example, you would be able to open any of these files. I mentioned briefly the NCCSV format. So in this case, it's interesting because you can have both data and metadata in the same file. So as you can see, the first 10 lines are about the metadata of this project. So you have useful information in the first 10 lines, and then at the 11th one we have end of metadata. So the rest of the file is about the data itself. So you can then just combine your metadata and data in the same tab in the same file. And just know that there are also some open format for geographic files. They contain geographic elements such as points, lines, polygons, and many of them are open. You probably all know about the shapefile format, although this one is not really open because it's still owned by ESRI, but it's largely used and really, user-friendly pretty much. You also have GeoPackage, GeoJSON, which is a JSON variant with simple geographic elements, and GeoTIFF, a TIFF variant supplemented with metadata that is relevant for GIS. So yeah, that's it for the file format. So now that we know which format to use and how to structure our folders and name our files, now we can look at what to put in said files and how to structure our data file and what are the required terms that we need to include when we want to share files either with, like I said, colleagues, or if we want to be able to reuse the files in the future. So just for starter, try to start your data at the first line. Write your title, your column title at the first line, and use the name of the tabs to include write the title of the tab rather than leaving some empty lines with just the name of the tab or the table. And try to have just one table per tab and not have like summary tabs, summary table in the same tab. Leave it for another one. And so we follow three very important rules that are among the best practices is to have these is to respect these three rules. So each variable must have its own column, each observation must have its own row, and each value must have its own cell. So ideally, you don't want this kind of table on the left. You should aim for the one on the right. And I'll explain in a little bit more detail how you can achieve that. So first, what is an observation, sorry. So it's the measure of a variable in a specific place and time. And here I have two examples. So let's say we observed 5 gray seals and 3 harbor seals on January 2nd, 2021 in Gaspé. Or we measured salinity with a probe twice in 2024 in the the rivière Brochu. So in both these cases, those are two observations. So they should both have two lines. So in the first case, there was one observation for the gray seal, or Hanicoerus gryphus, with a count of 5, and the 3 harbor seals, Phoca vitulina. In both cases, they happened in Gaspé on January 2nd, 2021, with these coordinates. Same thing with the Brochu River example. We measured the salinity, so we have 2 different values for salinity and 2 different dates because they happen at different times, but they're both in the same location in Brochu River at a particular station with those geographic coordinates. And then how to difference the variable and the value. So a variable is the class of a measure made on an observation. So for example, the scientific name would be a variable since it changes depending on what is observed. So again, if we go back to our example, we had 2 types of seals. So the scientific name will vary whether it was the harbor seal or the gray seal. And in the same way, let's say the date or the location could change as well if we had more than those 2 observations in Gaspé. Let's say there was another observation here in Rimouski, then the variable location would change and would have the value of Rimouski for a 3rd line. Because the value is the precise measure among the set of every possible variation. So for example, among all existing scientific names, we measured that it was Phoca vitulina, or among all the existing location, we measured that it was in Gaspé. Among all the possible value for the date and time, we measured that it was in January 2nd, 2021. So if I go back to our examples, the column would be our variables, the cells are the value for those variables, and these variables are what we observed during each of our observations, so for each of our lines. And when it comes to naming our variables, the best practices are a bit the same as for the naming of files. So you want to avoid using spaces, dots, and parentheses. Try to limit yourself to underscores and hyphens if you have to use special characters. Although contrary to data file names, you can still use uppercase. Name showed us a bit what is the camel case name. So for example, here scientific name, it's 2 words, but with no spaces, and the second word start with an uppercase letter. So yeah, try to avoid putting special characters, and yeah. And so when we said that each value must have its own cell, here's a good example. So I have a table on the left with different species and the number that we observe for each. So again, Abludomelita amoena here is not really a variable. It's really the value of a scientific name. So it's not a good practice to put it as the title of a column because it's not a variable in itself. It's more of the value of the variable scientific name. And the same can be said about the numbers. Those are the value of the variable count. And then if we look closely, we have 2 columns with Abludomelita amoena. Although one of them has the specification larvae, so that's 2 information in the same cell. one being the scientific name, and the second one being the life stage. So that's a third information, which should then have its own column, and we would call it the life stage column because that's another variable. And so the table on the left should look more like the table on the right with our three variable: scientific name, count, and life stage, which alternate between adult, larvae, and you might also have other types of other value for life stage. You could also have a variable sex, for example, or age. Also, although age would be a life stage as well, but there are many variables that you could measure on one observation. And again, when it comes to naming the variables, here at SLGO, we use many standards. Those are the three main ones, I would say. First, the Darwin Core for biodiversity data. It's a standard that I'll talk a bit more about it tomorrow, but just know that it's for biodiversity information, and it's used to publish data on the OBIS platform. So again, we mentioned briefly OBIS earlier. I think it was Juliette, and the Ocean Biodiversity Information System. And so they use the Darwin Core standards. So we also use it to make sure that the data that we publish can also be published on OBIS. We also use the CF conventions standards for climate, physicochemical, and other non-biodiversity variables, and also the NERC vocabulary as a guide for varied research fields. And all those standards are controlled vocabularies are in continuous development. So we keep track of all the new development to make sure that what we use as standards are up to date. And as I said earlier, there are some required variables when you want to share data. With every type of data, you should have it's best practice actually to include the date and, if possible, the time of day, but at least the year, because you want to be sure that when you reuse some data that you know when it was taken. And just for discoverability, if we're looking for data from 2023, but your data wasn't dated, then it won't appear on the research system. So having the date and again minimally the year, it's really useful to reuse data and compare it to actual one or past ones. Same thing can be said for geographic coordinates. We want to know where the data was taken. So again, if we're looking at data from around Rimouski, for example, and your data which was taken near Rimouski but wasn't geo-referenced, then it might not show up in the on the catalog, for example, or on the map you're using to get data. And the geodetic system is also important because we want to make sure that when we project that data on a map, that it's properly projected. And the measurement unit is also very important when you're taking measurements, because let's say you're doing some fish inventories and you're measuring them. Did you measure them in millimeters or in centimeters? So you want to make sure that this is that the data is accurate with the right measurement unit, so that when we compare it, we're comparing on the same scale. Additionally, if you're sharing biodiversity data, don't forget to use the scientific names, because those are more normalized than vernacular names. Sometimes vernacular names actually refers to paraphyletic groups. So many species from different genuses can have the same scientific name, the same vernacular name. So not providing the scientific name can be tricky when comparing data, when reusing data. And even more ideally, you can use the scientific name ID. So here I put a screenshot of the WORMS website. If you don't know about it, it's a website where a lot, if not all, the marine species around the world are inventoried with an AFIA ID, which is like a permanent ID for a specific scientific name. So let's say in 20 years, Spartina alterniflora was to change its scientific name for whatever reason. If we still have the AFIA ID, we can kind of trace back the changes that were made. And so if someone else in the future is sampling the same species that you identify as Spartina alterniflora last year, for example, then we can know that it's still the same species, the same organism, that it just changed its scientific name at some point, that we as human change its scientific name, so that we can make sure that we're still comparing the same organism and it's just the name that changed in time. And the same thing for sampling protocol. You want to make sure that you're comparing data that has been sampled in the same way, or that you're aware that it was sampled in a different way, to maybe compare those two sampling protocols. Like, for example, if you're doing a bird survey all by yourself, identifying the birds that you hear around you, but then the year after you go back to the same place, you do the same kind of bird survey, but you help yourself with a recorder to make sure that you really identified every bird that was around. Then in that second case, you might have more birds than the first year, but it might not be because the habitat was of a better quality. It might just be because you used a better protocol. So make sure you keep that information as well when you're sharing or archiving your data. So that was it for structuring your data files and what kind of variables are very important. But now, how to properly write that data in your data file is also a very important subject. And again, we studied best practices, and so I'm going to share with you some key examples and common issues that can happen when you're compiling your data and sharing it. So for example, with date and time, best practice is to ideally use the ISO 8601 standard. So again, like we said earlier, it's when you write the year first in 4 digits, and then the month and the day, all separated by hyphens. If you want to add the time as well, you can put it in a different column because it can be considered like a different variable. So you would have the variable date, but then the variable time of day could change as well, could be seen as another variable. But it's also fine to leave it as just one column and put those two value say together and just call it like one value of the variable. Let's say moment, actually, with the year, month, date, and then hour, minute, seconds. So if you decide to do that, make sure to separate the date and time with an uppercase T, and then hour column, minute column, and maybe seconds if you want to. And also don't forget to write the time zone, so relative to the coordinated universal time. So for example, here, if we are in Quebec during the summer, so it would be -4 hours, or you can just change the hour to represent the coordinated universal time. So just add a Z at the end of it after you changed the hour. And for geographic coordinates, write it in decimal degrees. It's the more common way to use it, to write it, and separate your coordinates in 2 columns, so one for latitude, one for longitude, and try to provide the geodetic system, as I said earlier. In this case, the WGS84 is the more commonly used one because it's interoperable with other information platforms. But if you use a different one, you can still write it down in your files. And when someone reuse your data, if you provided the geodetic system, they can then just convert the coordinates afterwards into the WGS84. Again, on symbols, only use underscores or hyphens. Try to avoid using other types of symbols. And for the decimal separator, try to use the dot rather than the comma, because when we use comma, it can influence the reading of a CSV file. So you might be familiar with that. CSV file uses the comma as a list separator. So if you put too many commas in your file, then you might have, when you switch back to Excel from a CSV file, then it will influence the reading of that file and add other column and just mess up your data. Also, on the measurement unit, don't forget to include it, and it can be included either in the title of a column. So, for example, in the left case, we have the total length in millimeter with its value. But if we want to look at it in another way, there are some standards that will say that actually this the case on the left actually has three variables other than the scientific name. That would be the variable that we could call measurement, which would be the total length, and then the variable measurement value. So each total length has a different value according to what observation was made. And we can also measure that the measurement unit of our measurement total length was in millimeter. So the example on the right might be a little bit more complex. So just know that the one on the left is perfectly fine. It's just that with, for example, when we share this data on OBIS, like I mentioned earlier, we will probably switch it to this kind of example on the right. Insert NA in cells without information, so avoid leaving empty cells. Prioritize NA for whatever the reason that there was an absence of value, because it's more easily recognizable by that data filtering tools. I think in English it's not too much of a problem, but it's just that in some other languages, like in French, for example, if we look at the example here, the unit for pH is actually there's no unit, so it's just not applicable. And here the temperature wasn't taken, so again, it's not available, so NA in both cases. But in French, it would actually be non disponible, so ND. But in that case, we would still write just NA, even if your data was, even if you're French, just use NA, because again, it's more easily recognized by data filtering tools. So avoid to use zeros or null or NaN. Just leave it to N for every empty cells. Also, it's better to just repeat information rather than merging cells. So I know it can be annoying to just write Rimouski a bunch of times for every observation that you made in said location. But when you switch to a CSV format, for example, just know that only it will separate the merged cells, and only the first one will have the value, and the others will be empty, or it will try to fill it with with nonsense. So yeah, just repeat information rather than merging your cells. In the same kind of train of thought, if you want to provide more information, prioritize the use of another column that you should name like remarks or comments. Because if we want here to mention that this observation of a three-spined stickleback was uncertain, like you're not sure of the identification, write it in a remarks column rather than putting, for example, color or writing it in bold. Because again, when you switch to CSV, you will lose this information. And just be consistent when you write your data, especially if you're if there's more than one people, more than one person writing in the same file, because different person can write a species name or a location in different manners, or the hour as well. And again, that's why using scientific name is the better option, because those are, as I said, normalized. So there's just one way to write them, instead of maybe having different ways of writing the same species. So you want to make sure that the same species is written in the same, has its name written the same throughout your file. And again, I will touch on why on some information that you will lose when transferring to a CSV file, for example. Here we have the format and colors. So if we use some kind of color code to provide the information on when the data was taken, so was it in winter or summer, when we switch to CSV, we'll lose that color, so we lose that information. So avoid using colors, and again, just use another column for, in that case, it could be another column called season, or just with the date, we can know when it was taken. So just a short summary of what I've been talking about. So avoid using special characters when naming variables. Oh, and just to mention again, we will provide you with these slides, so you don't have to take a screenshot or take notes of all that. We will provide you with them. So yeah, use the ISO 8601 format for the dates. Separate your columns for latitude and longitude. Enter coordinates in decimal degrees. Try to sum the content of the text to make it as concise as possible. Avoid merging, or just don't merge columns and rows. Move the measurement value, the measurement unit, sorry, in a separate column, or as I said, in the title of your measurement column. And yeah, use the dot as a decimal separator, and fill empty cells with NA. And also we add a bit more of another one, and it's to add a unique identifier for each event. So just to make it more unique, that's yeah, a best practice, but I'll tell you a bit more about it, I think, tomorrow, why IDs are important. Then I have a bit of useful technical settings to make sure that when you're reusing data, that you can properly reuse it and it's not too weird. So again, I think in English it's not too much of a problem, but in French, with all the accents that we might use, sometimes when we switch from Excel to CSV, there's like weird symbols that appears everywhere where there was accents on some letters. So if you're using, for example, Notepad to read that file, go to encoding and select UTF-8 and it should get rid of those weird symbols, and you will find the original data. And same thing for the CSV file. When you open it with Excel, often you'll see it like this, with just like the first column containing all the information of the other columns. So you can do it in Excel for this file, but you can also modify, you can also configure your Windows settings to use the comma as a column separator. Just be careful because it's gonna influence every other file that you open with Excel. So just remember that. And again, we will provide you with these the slides. So yeah, this is the way to do it. So later on, if you want to configure your Windows settings, you can just look at this slide. And yeah, so same thing for the configuration in Excel itself. Just know that you can go to data, text to column, select comma as a delimiter, and it will switch back to the proper table. And again, I'm sure it happened to many of you. It happened to many of us as well. Sometimes on Excel, the format of the cell is really important because for some reason, Excel often thinks that we're trying to write down a date, but it's most of the time it's not the case. Like you just want to write like an interval, and you write, for example, 3-22, and it thinks you're meaning you want to write a date. Like in this case, it's even worse. It's an area that was measured, so it's 3.22 in an area in hectares, but there was this date format that was month.day, and so Excel thinks that it's a date, and it can again it can mess up your data. So just keep an eye out for that. So yeah, sorry, I think I'm a bit early. So that's it for today, I guess. I can